So I welcome to all of you to this class of network analysis and synthesis. In this class, we will continue our discussion on Laplace transformation. In the previous class, we have seen a broad outline of the Laplace transform and how it is going to be advantageous if a circuit is given to us. In today's lecture, we will see that how Laplace transformation for a given function is done and how it is defined. So to start with, if we have a function ft, it is a function in time, and we want to get its Laplace transform. So this is indicated by this symbol L. So this we read as Laplace transform of, and this is also written as f of s, and this is defined as 0 minus to infinity f of t and into e to the power minus st dt. This s which you see here is a complex quantity which we have discussed earlier. S is equal to sigma plus j omega. Now we will see that for ft to be transformable, what is the sufficiency condition? For ft to be transformable, it is sufficient that integral over 0 minus to infinity f of t mod into e to the power minus sigma 1 t dt. This integration is going to be less than infinity. Now here we have one term sigma 1. This will be used later. This you remember. And we should note that this sigma 1 is real positive. Now we for ft we have got fs, so we call it a transform pair ft and fs. This f is small and this f is capital, so this we call transform pair. And this restriction is satisfied by most of the ft. Which restriction? This restriction. This is a restriction on ft, so that we can get this one, or in other words, we can get this transform fs. So this restriction is satisfied by most of the ft encountered in engineering. So whatever FTs we encounter in engineering, they satisfy this restriction. And why it is so that most of the FT in engineering domain, in the area of engineering, are going to satisfy this restriction? Because this term e to the power minus sigma t, this term is a powerful reducing factor. Fact, as we have seen earlier that e to the power minus sigma t, if you plot it, it is going to be like this. Now if any function, suppose even sinusoidal, whose magnitude, maximum amplitude is fixed, is not decaying, when it is multiplied with this, it gives a reducing sinusoidal. So this e to the power minus sigma t, which is going to reduce like this, will cause any function ft, which is a practical function from engineering field, will cause that ft due to this e to the power minus sigma t reducing like this, will make it mostly finite. Less than infinity means finite. So it is going to make it finite because it's a powerful reducing factor.